Welcome to the Enhancing Clinical Practice and Outcomes stream of the SNOMED CT Expo 2021. My name is Peter Groves-Williams. I am a technical specialist at SNOMED International, and I will be moderating today's session. Please use the live Q&A in your AirTouch device to type your questions to the presenter. All questions will be answered at the conclusion of the presentation. I'm now pleased to introduce Anthony Shek of King's College London, who will be presenting an automated clinical natural language processing approach to structure and organize free text electronic health records from London tertiary care. Anthony, please proceed.
Thank you for the introduction, Peter. So first of all, why do we need an automated clinical text extraction system? And so first of all, this really revolves around the electronic patient health record. And the majority of clinically valuable information is really held within this record. But the problem is looking at these electronic patient records is actually unstructured, meaning that there's no data standardization requirements, which although makes it perfect for day-to-day communication and direct patient care, and communication of results and disorders and disease and what's happened to the patient, this can be from a secondary or from a data extraction point of view, this can be quite difficult to extract the information from this free or unstructured text. So if I had a question that if I wanted to extract all mentions of epilepsy diagnosis, I could do a simple Control F or a rule or type in combinations of words. However, you'll see that in this document, when I look for the word epilepsy, I get the hit epilepsy clinic and the epilepsy as the last part of the diagnosis. So it's not really ideal. So what do we actually want? Ideally, we would want a context-dependent extraction of the epilepsy diagnosis, where the mention of epilepsy in epilepsy clinic isn't recognized. And only the diagnosis, depending on the context and whether it's spelling mistakes or acronyms, it still gets extracted. This is certainly possible to do manually to extract these terms and link it to SNOMED. However, it could be potentially a huge amount of work. And so this field of automated extraction or having computers to extract information from free text is known as natural language processing. And so there are two ways. The first one being the rule-based, and the epilepsy example was a really good one of this. And the other one, which I'll be presenting to you today, is a more machine learning-based technique where you don't need to specify the rules per se, but what a model or machine learning model will do will learn through examples. And so just a background of the scale of the problem, looking at King's College Hospital, one of the largest hospitals in London, it holds over 18 million electronic patient health records, and the majority of which is unstructured. And so, as I mentioned before, these electronic patient records are primarily developed for direct patient care, and the majority of the clinically valuable information within this text is trapped. And so, first of all, I want to introduce you to CogStack, which is an information retrieval and extraction platform. And the reason for CogStack and how it works is that within a hospital, data is often siloed across multiple clinical record systems. What CogStack does is brings together all the data from these different sites and sources and brings together the unstructured sections, the body or the contents of each document, and also the metadata and the blood results and tests or the structured results. Whether these data are presented in PDF formats or Word documents, or even scanned documents processed by an optical character reader. These can be batch processed, harmonized, stripped of their different structures and centralized into one single area, which can then be queried. So here's an example of how CogStack looks like from the front end, where I can search the body, where the body analyzer represents the contents of each document. And I can search for keywords such as 2017, and I can look for keywords within the whole of EPR. relating. And so this example, I'm looking for first seizure. And so you can already see that this is a rule-based technique, and it can get quite complicated very quickly, even for a simple query, such as looking for a first seizure. But already very powerful tool as it operates in near real time. So on the left-hand side is how a typical document in King's College Hospital or an EPR document would look like. And on the right-hand side is how Cogstack would strip it with all the key terms highlighted in green. However, as you can see, first seizure clinic is not ideal because I don't want to be extracting that, as that's not really referring to the patient. So what is MedCat? So MedCat is a tool that we've built together at King's College London, and it stands for a medical concept annotation toolkit. And it simply links free text to a structured or standardized terminology such as SNOMED. It works by using a simple neural network architecture, specifically Word2Vec, and several other algorithms that I won't get into specifically in this talk. And the way that it works, it disambiguates words or phrases dependent on the context in which it's mentioned. And the huge advantage of this is that together with the SNOMED CT library, it can take advantage of the concepts, the standardization of all the synonyms, and also the hierarchical nature, specifically the ISA relationships. And so the main purpose of this tool is really just to automate and standardize the accurate extraction of clinically valuable information from these unstructured textual documents. And on the right-hand side is just a simple QR code where if you want to test it out yourself and how it would work, feel free. And so this tool has potential. Before I get into how this tool looks like and how it works, there's several potential ways of how it can feed back into SNOMED CT. The first one, it enables domain experts or anyone with a clinical expertise with a topic, but with little or no knowledge of SNOMED, to engage and explore SNOMED CT to annotate the text. The second one is, as they annotate the text, they can, as they annotate and as they work, they will add commonly used synonyms or phrases of these SNOMED concepts. It can identify real world missing SNOMED concepts, because as they annotate, if they come across a concept that isn't within the terminology or within that edition, it gives the opportunity for the annotator to add new concepts. The last one is that it allows for context to SNOMED CT linking. And so this really reduces the need for the concept duplication for different contexts. So for example, history of disease, risk of disease, family of disease, and actually the disease concept itself. So it gets rid of all that and it just mentions, so you only need really the disease concept itself. And so let me just go through the whole workflow, and then it will become a bit clearer. So first of all, Cogstack is used to identify and retrieve all the documents across the whole trust. Cogstack retrieves each row represented as a single document, and each row has several structured fields with all the metadata of the document and other results and blood tests, etc. at that time. So as I said, each one is linked to a specific document, which is represented with this fake document that I've written on the right-hand side with the unstructured textual information. And so having a look at the main platform where the users of MedCat will primarily spend their time, by users, I mean clinicians or anyone with this expertise, is that MedCat will bring forth examples of what things are. So for example, double cortex syndrome, in this example, it's recognizing it as subcortical band heterotopia. And it's your job or the annotator's job to label it as a correct, incorrect, or get rid of that from this particular use case. And this trainer uses an active learning process, which means that as you annotate, the easier it will become because the model starts learning and copying your pattern of or style of annotations. So it becomes very easy, very quickly. And if it misses something, so for example, in this context, her non-epileptic seizures, if it incorrectly identifies it as epileptic seizure, what you can do is highlight the proportion of the text. You can add the synonym, choose to select the correct SNOMED code, link it to that, and then you can add the term. If the concept doesn't exist, it's possible, and there's options in the tool to define your own concepts and add a custom unique term identifier. And so here's an example of malignant middle cerebral artery infarction. You can simply add that and then propose it secondarily to SNOMED to add it into their terminology. Another thing is that when you annotate, there is another option, which is an annotation of an annotation, which is a meta-annotation, which we like to call meta-annotation. And that essentially just captures the contextual information of that label. So here, under anti-epileptic medication, MedCat has labeled it as anticonvulsant. And so there are options on the right-hand side where you can describe really the context of it. So whether it's the patient, it's false and recent. And so as you annotate, the model learns these patterns. And so depending on which combinations you want to be extracting towards the end, it could be very well possible. And these options are totally customizable depending on your use case. So if I was interested in extracting mentions of past medications, I would, for the patient, it'd be patient, true, past. So on the left-hand side is an example of how MedCat would annotate and label the documents. So in gray is a prediction of what MedCat is labeling, and each gray box so represents the prediction of the model, and in bold is the respective metadata. What it can do is infer a degree of structure, and you can choose any top-level heading, however high or low level within the SNOMED hierarchy. So under here, under epilepsy, the code for epilepsy, it says there are 3 mentions of epilepsy in this document, including the children of epilepsy. So having a look at, there's 1 mention epilepsy here, there's juvenile myoclonic epilepsy, which is labeled, and there's also the acronym JME. But here's an example of an unfiltered annotation, but MedCat gives you the flexibility of filtering by your disorders, symptoms, or customizable terms or concepts of interest. So once MedCat has processed it and aggregated it, you can then link the structured data from CogStack with the respective information from within the documents. You can then group by patient, hospital admission, departments, or diseases, and manipulate the data in whichever way you see fit. So overall, CogStack retrieves all the documentation across the hospital. Then there is a process of training where a subsample is selected, clinicians have a look and produce benchmarking materials to validate the model. And then once the model has been trained, you can then extract the terms and then infer a degree of structure. So over here is a good example of how under the top level heading epilepsy, focal epilepsy is extracted as localization related epilepsy, which is a type of epilepsy, and so it would count. So once again, showing how MedCat takes advantage of the SNOMED hierarchies. And once a model is trained, you can simply retrieve, extract, aggregate, and process. And this works in a very rapid fashion. And it can be, we have done 19 million documents in under 2 days of annotating everything in SNOMED of all concepts. We also demonstrate that it's possible to transfer models between hospitals and that it has an additive effect. So we show that after training and at King's College Hospital, once we transfer it to a site such as University College London Hospital or the South London and Maudsley hospitals, there is only, so a transfer of learning shows that there's a degree of increased performance, but then further training within the site or fine tuning helps boost that little bit of evidence, which generally means that the more annotations or the more work and across different sites, the better the extraction models will be. So overall, CogStack brings together all the records from multiple clinical record systems in a live or near real-time manner. The structured data is already in a machine readable context or process. MedCat processes the free or unstructured text and infers a degree of structure. And then from this, a number of applications then arise, which can be cohort detection, automated coding, clinical decision support, and especially data exploration for research. And especially nowadays, we're looking at predictive longitudinal modeling. And so here's an example of just how it's been used, or a few selected publications about how it's been used in a numerous COVID-19 circumstances. And essentially what it does is we can choose a cohort to see, well, who has a positive PCR test for COVID-19, and what are the associated symptoms with which sort of outcomes as well. And all these research publications now allow, or this tool allows these researchers to use SNOMED as part of their process. And so I just wanted to say thank you very much for listening to this talk. And I'd like to shout out a special thank you to the rest of the Cogstack team. And once again, the links and the QR code to a demo where you can try out the models and tools yourself, and the paper for the specific performances is here. Thank you very much for listening.
Thank you, Anthony, for your presentation. Can I ask that attendees give us a moment while we switch over from our pre-recorded content so that Anthony can address the questions you have been submitting live? Please note that this session will be available on the event platform for the next 3 months. And we're live. Thank you once again, Anthony. Can I ask delegates to find the live Q&A button, which is on their AirTouch device, if they would like to submit questions? I'm not seeing any questions currently, so we have 13 minutes left in this slot. So if anyone has a question for Anthony, please do type it in now. And if not, I had a few questions while I got to watch the presentation over again today, Anthony. A question that came up for me was, what was your biggest challenge in this work? What nut did you really have to crack?
Sure. So it was certainly identifying which algorithms are the most suitable for this purpose. Because lately, I guess in the field of machine learning or artificial intelligence, there's new discoveries being made and published nearly every 6 months, very rapidly. And so really finding out which tools, which may not necessarily be the latest ones, are most suitable for this task, and selecting it and putting it together in a format that is most suitable for this information retrieval task is certainly the most challenging.
Great. I've found the questions now. They are coming in. This one from Cyprian Virgil says, can you please explain the linking between the structured and unstructured data?
Sure. So it's simply that when you retrieve and look at use Cogstack to retrieve all the documents, each document is associated with the metadata. So which patient does it belong to, the ages, the time that they came in, and it's because it's structured, it's in these rows, and you could see this as a spreadsheet, that it's just a simple join, that you have a certain document ID, and it's simply a case of merging based on the document ID of the unstructured with the structured text.
Okay, thank you.
Fantastic.
James Teo asks, what are your thoughts about the newer NLP architectures like transformers versus your approach with, they're jumping around, word-to-vec?
Word-to-vec. Okay, so that's quite a technical question. But so one of the hottest topics, I guess, in AI and machine learning right now is the ability to use transformer-based models. And without, I guess, getting into what those are and what they mean specifically in too much detail, transformer-based models right now in the field of NLP is what everyone is using and what everyone is wanting to use. However, we don't use it. And the reason for that is that we leverage the structure and ability of SNOMED, so that each concept represents one defined area of knowledge. And so using this word-to-vec is much more suitable for this task rather than transformers. Whereas another task, for example, that we are using transformer-based models within this platform is for de-identification process, where a concept such as a name can have a near infinite amount of definitions. So everyone has a different name, whereas, and it can have 1 million synonyms really, or infinite number of synonyms. So I think transform-based models would be perfect for that use case, whereas leveraging a structured or standardized terminology such as SNOMED, Word2Vec is the better approach here.
Great, thank you. There are a couple of questions that are similar here. Hadras Bitran says, how many documents were in the corpus of training data set, and how do you avoid overfitting to specific examples? And Alice Pannier says, how big a training data set do you need to use this approach?
Okay, so I'll probably start with the latter question. So do you need? So it really depends on your use case, really. So if you want to be annotating 1 million documents, ideally, the best answer to this is you want as many as possible. However, depending on what you actually want to be extracting, the number of documents that you actually need to be training the model vary significantly. So words or concepts that don't vary very much, such as the general term epilepsy. You don't really need many documents at all, because epilepsy is just epilepsy. Whereas other concepts such as seizure can be represented as fit, SZ, attack, episode. And so you really want to make sure you take a sample that's large enough that encapsulates or captures these different examples. So I guess the short answer is the more the better, and make sure that the sample is is sufficient to capture all the different ways of expressing the concept. And I forgot the previous question.
It was about how to avoid overfitting examples.
Sure. So within the MEDCAT algorithm tool itself, there are ways to customize the amount of learning. So we're not really overfitting is not really quite an issue for this tool, because ideally, whenever it looks for a term epilepsy, you want to really have it learn. So there's really, which I didn't explain, there's 2 stages to the MEDCAT model process. One is the unsupervised process, where you take a corpus of documents and you allow the model to read and learn for itself. And then there's a second stage, which is the platform that I presented in this talk, whereby that a clinician will go through, often a much less sample, just to double check and change everything to it, and customize it. So you need to just capture all the different ways of expressing that concept.
How long does training the model take?
So I think this reflects in the previous question. It really varies. So the unsupervised training step is within a few hours. It is scalable depending on the size of your documents, really. So if you're looking at 20 million documents, you could be looking at about 1 to 2 weeks, but it's completely scalable with more advanced computational techniques or facilities or capabilities. But then the annotation process really depends on how many documents you're annotating, how familiar the annotators are with the tool, and just making sure that they're doing it the right way, and you need to validate it too. So it really depends, but most projects take about a month really to annotate or train. But then you can just build off those pre-existing models, so it should become less and less needed to train.
Sure. Thank you, Anthony. Question sort of in a similar vein from Erin Holmes. How much human interaction is required with the model? There was a slide on selecting the correct term, but then there was a metric on a 2-day throughput of millions of documents. Sure.
And so I think this goes back to I guess 2-day throughput is just to annotate, right? So you have the unsupervised training, where the model goes through and tries to calibrate it itself. Then you have the supervised training step, where the clinicians or domain experts are correcting and labeling certain terms or keywords or phrases. And then lastly, it's just the annotation. So the annotation step is really quick. So once you have a trained model, it works currently on a simple Mac PC at about 50,000 documents per hour. Yeah.
Related question from Mark Banks here. He says, great work. Have you had good uptake from the clinicians to make the annotations required?
Absolutely, absolutely. Because I think at the end of the day, clinicians, they, they want to, I mean, they need, as a requirement, they do audits or they want to do research. However, they don't want to really be going through thousands and thousands of documents by themselves. And this tool sort of offers an opportunity to automate potential audits, keep them running live. Because once you have a trained model that's been validated, you can just keep on having it running in the background. And as well for research, you can look at scales that are potentially unforeseen or unheard of when compared to a manual process as well. Sure.
Thank you.
So I'm just looking at the chat and I see a question about how linking to UMLS may not be suitable, as UMLS uses a USA extension of SNOMED CT, and spellings may create problems as UK spellings will be different. So I guess it really depends, and you really want to train a model based on your own custom data sets. So and that's where this tool is advantageous, is that you want to be really training and validating your tool based on your own local data set for your own use case. And so although I work in and live and work in the UK, there are doctors from all over the world that write in different manners of expression using different ways of or forms of spelling. And this tool will be able to disambiguate between American spelling, spelling mistakes, using acronyms, and yeah, so that's one of the strongest advantages of this tool. It's not really regional specific, but if you want to take a model that has been trained in the UK to the US, you probably want to do a little bit of a validation to understand how much further training or how well does this model perform as well. Cool. Are there any more time for questions? I can answer a few more. There's loads of questions coming in.
We have to have 2 minutes, 35 seconds.
Cool.
Do you see a question you like?
Are there any plans to utilize any additional extensions of SNOMED CT, US, Canada, Australia, etc. under the hood? So yep, absolutely. So right now we use the UK extension, and I've used international extensions, and there are ways on this platform where you can add any form of extension that you would like. You can also add your own custom extension and build your own custom extensions, which we've done to supplement SNOMED CT. So we've built and extended it based on EEG terminology, specific terminology, and especially neuroimaging, because that's not really well defined or created yet in SNOMED. So you can absolutely customize it however you want, and there are tutorials in the GitHub how to use whichever extension that you want to build and train your own models. And but ideally you want to be training it on a subsample of the data set that you would want.
Super.
Cool.
Anthony, you said that you were able to identify concepts that were potentially missing from SNOMED. Are you aware of the pathway to get that back into either the UK or the international edition? Is that something that's been looked at?
Yep, absolutely. So, but I think at the moment, due to the speed and uptake, we're just really collecting all the different concepts and phrases. And what we do is we partner up with the clinical coding teams at the different hospital sites, and they have a bit more of a direct interaction with the NHS Digital, who's the main maintainer of the SNOMED UK extensions, and they facilitate and communicate based on that. Yeah, cool. And I think that leads on to a great question. Could clinical coders support model annotations and validations? So I guess, first of all, absolutely anyone can annotate and train the models. And clinical coders are, I guess they're people that really, they annotate documents or patient episodes using ICD-10. So the great thing about SNOMED is that there is a direct mapping. And so this tool can actually be used for annotation of SNOMED and then grouped by your patient episode. to then
Anthony, I'm afraid we are out of time
used.
there.
No worries.
Thank you very much for your
Cut it
session,
off.
and I'm sorry
No
we had to cut it short. I believe you will still be
Absolutely.
able to answer the questions in the chat continuing
Chat.
and the Q&A.
Absolutely. Look forward to it. Thank you for having me.
Thank you, Anthony.
Thank you. Bye-bye.